Let's have a look at factorising quadratics. But before we do that, let's fully understand it by really thinking about what we're doing when we expand brackets on an expression like this. So going back even further, when you first learned how to multiply a two-digit number by another two-digit number, it probably looked something like this. And you probably recognise that there's four sort of parts to this problem. We split the 14 up into 10 and 4, and we split the 32 up into 30 and 2. Now, we don't even realise we're doing this, but when we complete a multiplication algorithm like this, we're really doing two 4s to get our 8. And then we're doing two 1s, but it's really two 10s, isn't it? Because this 1 is in the 10s column. And we know that two 10s is 20. Two 1s is also 2, but placing a 2 in the 10s column gives you 20, doesn't it? Then on the next line, we need to put a 0 down, and we do that because this isn't really a 3, it's a 30. So we do 30 lots of 4, but by doing 3 4s with a 0 on the end, we get our 12, which is actually 120. We carry our 1, and then we say we want 30 10s, but we can actually just say 3 1s and 3, add our extra 1 to make 4. Then we need to add all of these parts together, and we get our final answer. Now, what's going on here, these four parts, can be really simply explained by looking at the area of a room that might be, say, 14 metres wide one way and 32 metres long the other. We can split that up, just like we did here, so that the 32 metres is a 30 and a 2, and the 14 metres is broken into 10 and 4. We've still got the exact same sized room. Now, clearly there's four parts to this room now, and we can see that the size of this part will be 10 times 30, which is, let's go colour, 300. And that will be in units squared, obviously. And then this part here will be 30 times 4. And this part down here is 2 times 4. And here we have 2 times 10. Now, if we add up all those four numbers, we should get the exact same answer. So you can see why there's four parts to the problem. Now, moving along to this should now make even more sense, that we have to do the 10 times the 30, the 10 times the 2, the 4 times the 30, and the 4 times the 2. And there's four parts. Okay, so how is all of this going to relate to this sort of problem? Well, when we go to expand our brackets on something like this, we're using the FOIL method. FOIL because we like to think of firsts, outsides, insides, and lasts. And they relate to these lines that I've just drawn, which helps me keep track of what I've multiplied by what. So applying the FOIL method to something like this is important because I actually can't do the bracket part first. If I had this problem, I could do it by saying, well, 10 plus 4 is 14, and 30 plus 2 is 32, so really I want 14 times 32, and I could punch that into a calculator if I wanted to. I can't put x's into my calculator though. So to tidy up this expression or make it look different, I need to use this FOIL method. So the firsts means the first term in this and the first term in that. X times x is x squared. Outsides, that means the very outside term on each part. And we have x times positive 2. Notice that this sign stays with the thing that comes after it. And 2 lots of x is 2x. It's positive 2x, so I just put a big plus 2x there. Then I have I, which stands for insides, and that's the 2 on the inside here. We have positive 4 times positive x, and that makes positive 4x. And then we have 4 times 2. Positive 4 times positive 2, and that makes positive 8. Now, in this case, we can see that when we have 2 terms in each part, we're going to get 4 terms in the expansion. But sometimes a couple of those terms will talk to each other. These two here are like terms, which means that we can add them up. If we've got 2 x's and then we get another 4 x's, altogether we've got 6 x's. So we can tidy up here and say we have x squared plus, these two come together to make 6x, and then we have 8. All right, now the process that we need to learn today, factorising a quadratic comes about when we look at an expression like this and we have to turn it back into this sort of thing with the brackets. So let's have a think about what we know. We know that we got this first part here, the x squared, from doing the firsts, and that seems fairly obvious and straightforward. So if I see something looking like this, I know that I need to draw up some brackets, And the first thing I can do is put my firsts in there, because I know that x times x will be x squared. The other thing you should think about next is your lasts, because the lasts, when they multiply, aren't going to have any x's in them at all. So that's going to give us this term. So I say to myself, all right, the lasts multiply to make 8. So what are the factors of 8? Well, let's jot them down. We have 1 times 8 and 2 times 4. They're the only factors of 8. And remember, factors always come in pairs. So which of these pairs can I put in here so that the insides and the outsides will add up to 6 x's? Well, you'll notice that whatever number goes here is the number of x's I'll have for the insides, and whatever number goes here is the number of x's I'll have for the outsides. So I really need to just choose two numbers that multiply to make 8 and add to make 6. And if you jot them down, you can clearly and easily see I need the 2 and the 4. 1 and 8 adds to 9, so that's no use. So I put my 2 and my 4 in. And then the last step, check it. Expand it back out using the FOIL method and check you get back to what you were given. So firsts x squared, insides and outsides, 4x and 2x, that makes 6x, and the lasts makes 8. So I've got it right. Okay, so let's practice factorizing some monic quadratics. Now a monic one is one that just has x squared here. It's called monic because mono stands for 1, and there's only one x squared. It gets a little bit trickier once we have a number other than 1 there, but let's get good at these ones first. All right, so we know that we've got a quadratic because we can see that we've got some x's squared, or perhaps it's y's or some other pronumeral. And we've got some that aren't squared as well, and we've also got some numbers. And that tells me that if I've got 3 terms and they're in that sort of format, then I'm going to have this situation with 2 sets of brackets with 2 terms in each. Now, quick inspection here tells me that all of these have x squared in them. So you can go ahead and start by saying, all right, I must have x as the first term in all of these questions. Now, you'll notice something else that I've done here, a little bit tricky, but I've decided to just use 12 every time so that we can get onto something of a roll with our method here of spotting some shortcuts. Now, we know that the lasts in each case is either 12 or negative 12. Now, instead of thinking of the factors of 12 and the factors of minus 12, I like to just jot down the factors of 12. Just put them in your margin or somewhere where it's easy to find them. Now, they come in pairs. 1 times 12 is 12, 2 times 6 is 12, 3 times 4 is 12. And I always jot them down like that, starting with 1 and then going to 2 if it has it, and then 3 if it has it, and so on. And you'll notice that as the factor on this side gets bigger, its partner gets smaller. And that's really helpful because as each one comes in and gets closer and closer, you can then tell, once this number and this number have nothing between them that's a factor, that you've found all the factors. So that's a really good little check. All right, I've got those there, and they're going to help me with all of these questions. So which pair of these numbers can I put here and here so that when I add them together, I get 7? Well, easy to add these. 13, 8, 7. It's these two. Positive 3 and positive 4 make positive 7. So put them in, and then the next step, check it. Use the FOIL method. X squared, 4x and 3x will make my 7x, and the lasts will be 12. Yep, it's right. So you can check that you've got the right answer before you move along. All right, now I want factors of 12 that add up to negative 13. Now, what's going on here? How can we get negative 13 when we add these numbers? Well, they must both be negative. Now, don't forget that when you're multiplying numbers together, a positive times a positive will give a positive. But a negative times a negative will also give a positive. So if your lasts are positive, but your middle term is negative, you can be sure that it's this situation. Both of your lasts must be negative. So if both of these are negative, what do they add up to? Negative 1 and negative 12. Oh, there it is already, negative 13. We've found it. It can't be these ones because minus 2 minus 6 would be minus 8, and minus 3 minus 4 would be minus 7. So it must be these two, and they must both be negative because that's the only way this could work. So put them in and then check them. The first is x squared, outside's minus 12, inside's minus 1, so minus 12x minus 1x gives us the minus 13x, and then negative 1 times negative 12 gives us the 12. All right, next we want factors of negative 12. Now, if you have a positive and you multiply it by a negative, what do you get? A negative, that's right. So if we know that we've got a negative, it means one of these guys must be positive and one must be negative. So what I like to do is, rather than sort of lock myself into thinking which one might it be, I just prefer to say, well, how can I play with these numbers, these pairs here, so that I'm taking one away from the other to get 4. All right, can you play with 1 and 12 to make 4 just by adding and subtracting? No, you can only make numbers like 11 or 13. Can you make 4 when you're dealing with 2 and a 6? Sure, you can do 6 minus 2. Can you get 4 when you're adding and subtracting 4 and 3? No, you can only get numbers like 1 or 7. So it must be this pair here. Now, if you're not sure which one's which, just put the numbers in and then think about it. We need positive 4. That means the 6 needs to be positive 6x. So put the plus in front of the big thing, and then the 2 needs to be minus. Then check it. X squared, 6x minus 2x, that gives 4x. Negative 2 times 6, negative 12. It works. All right, now we want factors of negative 12. So again, alarm bells. If we've got negative 12, one of the factors must have been positive, one must have been negative. So how can I add and subtract these pairs of numbers to get negative 1? Well, this one jumps out at me. 4 minus 3 is 1, but 3 minus 4 is negative 1. So we need the 3 to be the positive thing, and we need the 4 to be the negative thing. And it doesn't matter, of course, which way you write these around. The same answer, can be written 2 ways. Now check it. X squared. We've got the 3x minus the 4x. That gives us the negative x and negative 12. Got it. All right, we want factors of positive 12. So we know that they need to both be positive or both be negative. But they need to add up to 8. That tells us they must both be positive. Which of these can add up to 8? 6 and 2. Easy. Put them in. Check it. X squared, 6x, 2x makes 8x, and 12. Got it. And the last one, we need factors of negative 12. So one must be positive, one must be negative. They need to add up to 1. All right, how do we make 1 here? When one of these is being subtracted from the other, it must be 4 minus 3. They make 1. So we do 4 and minus 3. Then we check it. Always check it. X squared, 4x minus 3x is x, negative 12. And then we've got it.